Okay, so this video is going to go over how to use Coulomb's law. I would encourage you to fast forward, rewind as much as you need to. Some of this might be very obvious to you, and I would just, again, encourage you to make use of this in the best way possible and fast forward through calculations if you need to or anything like that. But Coulomb's law, we looked at it in class. You all have sort of been investigating and building your understanding of Coulomb's law in our simulation, looking at how charges interact. But again, it lets us calculate an electrostatic force. That's what that Fe piece of this equation stands for, electrostatic force. And it depends on, first, K, which is just some constant that scientists have determined over years and years of running experiments. It's 9 times 10 to the 9th. I'll show in a second how we get that over here in our just Googleable calculator. These Q's are charges, and this R is a distance between those charges. And we could also quickly go over the base units for all of those things. Our base unit for charge is coulombs, which you all have been seeing in this simulation as microcoulombs when they have this little Greek symbol. That tells us that it's a micro something, so there are like micrometers or micrometers. There are like micrograms. It would always have that symbol in front. But we're just going to know that our base gram is coulombs. Distance, our base unit is meters. And our base unit for force is, not F, that is newtons. And if you were really interested in units, I could go over in a different video possibly where these units came from. But basically, the units on that constant just allow the equation to work out so that we end up in newtons for this electrostatic force. So there are going to be 3 types of problems that I show how to solve here. First, maybe the easiest one where we're just solving for a force. Second, we're going to go over how to solve for a missing charge, a missing value of a charge. And then at the end, we'll show how to solve for this missing distance if we know the charges and the force, but we don't know that distance. So let's go over again that first type of problem. That is hopefully the easiest for you. And the reason that it's the easiest is because this equation is already solved for our force. So let's say that we have 2 charges here. I'm going to keep all of the charges positive for this video, just to keep things a little simpler, and you'll figure out how to deal with negative charges on your own. So we have a positive charge on the left and on the right. Let's say that our left charge is positive 0.005 coulombs. And let's say that our charge on the right is positive 0.008 coulombs. And that actually, even though those are pretty small numbers, that actually would be a lot of charge built up on these 2 things. But we're not looking at reasonable numbers right now. We're just getting a feel for how to use these actual equations. And we need to know not only the charges, but we need to know the distance between them. So let's just say that these are 2 meters apart. Right? And then when it comes to solving for what's this electrostatic force, we just need to make sure that we're plugging all of these numbers into the correct spot in the equation. And in fact, let me change the color of this distance so that you can see exactly where I plug it in when we get to that part of the equation. 2 meters. So we're going to plug in first our constant, 9 times 10 to the 9th. Then we're going to plug in our first charge, 0.005 coulombs. And then we're going to plug in our second charge, our 0.008 coulombs. And at the end of all of that, we're going to make sure that we divide by our distance, 2 meters, and don't forget to square that distance. Right. And then over here on the right, I'll show how you can plug these numbers in. This is just a calculator. If you Google calculator, it'll come up with this. So I wanted to show you how you could plug these numbers in on a calculator that at least I know hopefully everyone can get to. So this 9 times 10 to the 9th, that if any part of this gives people trouble, I think this might be the one. To plug that in here, we go 9 times, and I'm just going to go 10. And then to plug in that to the 9th part, that exponent there, I'm going to click this button that's x to the y right there. And that'll pop up with this little exponent button, and then I can put in a 9 there. So 9 times 10 to the 9th, and then I'll just hit enter so that I sort of have just one simple number to plug in. And then I'm going to multiply by the rest of this equation times 0.005 times 0.008. Okay, and then I just hit enter again so that it would just have one number that I'm working with. And then I want to divide by, and I'm going to put this in parentheses. This is a good habit to get into, even though I know you all know what 2 squared is off the top of your head already. It's just a good habit to get into putting our distance there, whatever it is. I clicked this x to the y button again because we have another exponent, and that's 2 to the 2nd power. And then I'm going to hit enter and close parentheses. And that gives us our final force of 90,000. And again, I knew that this was in newtons because this is a force for us, and I should have labeled way back when that this was an electrostatic force. And in terms of work that you would need to show, this plug-in step is plenty. In fact, that's the main work that I would ask you to show. Just show like the numbers that you're plugging in, and then it's okay if you skip sort of like from there to this answer. But this is like when we're solving equations, it's important that you show these plugins so that if you get it right, I can see like sort of how you got it right, and if you get it wrong, it makes it easier for me to sort of see maybe what went wrong and give you help if you need it. Okay, so that was the first type of problem, solving for force. It was pretty much just plugging in because this equation is already solved for force. So let's look at a problem where we now know one of these forces, or excuse me, one of these charges, and we know the force acting on them, but we don't know what one of those forces is. So let's say that this pink charge right here, we don't know what the value of this one is now. But maybe we do know that the force acting between them, so I'm going to draw a little vector for this force, and you might have noticed the correction I made. At first I drew this arrow pointing towards the other one, but since these are both positive, we know that they should be repelling each other. Let's say that we know that the force, and I'm just going to write it over here because I don't have a lot of room to the left. Let's say the force that's acting on this charge is 800 newtons. 800 newtons of force pushing this positive charge to the left. And since we know that these are sort of force pairs, or we observed that in the simulation, that means that that must also be what's acting on this other positive sort of mystery charge. So let's take a second to set this problem up, and we're just going to start off plugging everything in that we know. So we know that our electrostatic force is our 800 newtons. So I plug that in here. Now on the other side of this equation, right, so basically what I did is I just plugged that in to the FE part of our equation. Now we're going to work on the right side of this equation, right? So 800 is equal to 9 times 10 to the 9th, still the same thing, times our 0.005 coulombs, times some kind of charge 2, so I'll just label that Q2, I'll leave it like symbolic for now, all still divided by the same 2 meters as before, making sure that we square it. And I'll get rid of that unit because I didn't write my units anywhere else. So in order to solve for this Q2 up here, let's get everything else in this equation to the other side, right? So if I'm right now dividing by 2 squared, why don't I cancel that out by multiplying both sides of this equation by 2 squared? Let's take a second to do that, and I'll just show that briefly here. So I'm going to multiply both sides of this equation times 2 squared. That'll cancel this out. And so over here in my calculator, what I'm going to plug in is I'm going to do our 800 times, and then again, I know you all know what 2 squared is, but just as a good habit, when you have more complicated numbers there as a distance, it's a good habit to get into using this sort of exponent button and putting things in parentheses to keep them separate. So 800 times this 2 squared, that canceled out our denominator, and that leaves us with 3,200. And now we don't have to write this 2 squared in the bottom anymore. Now we're just left with 9 times 10 to the 9th times 0.005 times Q2. And I could put that in parentheses still too. Okay. So, drag down a little bit, give ourselves some room. Now what I want to do is I want to cancel out these two things. So right now, all of these things, or both of these things, are being multiplied by Q2. So if I want to cancel them out, I need to do the opposite, and I'm going to divide this whole equation by both of these things. And I'm skipping a little bit of a step where I'm combining those two steps. If it's more comfortable for you, you can feel free to do this division step in one step, but to keep this video remotely brief at all, I'm going to do both of these at the same time. So this will cancel out our 9 times 10 to the 9th over there. That's going to cancel out our 0.005, but I need to make sure I do this division step on both sides. So let's take this 3,200, divide it, and now I'm going to put this in parentheses. So 9 times 10 to the 9th. So 10, again, I'm going to click this x to the y button to get our exponent. And then times, because we need to sort of divide by this whole thing multiplied by itself. So I'm going to click again, multiply 0.005. There. So just notice I'm taking whatever is on this side and dividing by everything down here. And since these two things, we're dividing by these things that are being multiplied, I'm just sort of including all of that within these parentheses. And then I'm just going to hit enter. And whatever we get there, that is what we're left with as our Q2, right? Because everything else has sort of gone away. So 0.0, and that's 4 zeros, 71 coulombs is equal to Q2. So I've rounded because our ones are just going to keep on going forever. So that's how you solve for one missing charge. Basically, it just requires a little more algebra than solving for a force did. Okay, now we're going to look at how we would do, I think, the maybe most algebraically involved problem involving Coulomb's law, which is solving for an unknown distance between two charges. So that would mean that we know the value of both charges now, and we know the force acting on those charges. The question for us would be, how far are these two charges apart? So let's come back to this same diagram. Now we don't know the distance, that little orange part, but we do know our force. Let's change up the force a little bit. Let's say that our force is, instead of 800 newtons, let's say it is 500 newtons. I'm not sure why, but let's just say that. And then this charge over here on the right, let's say that that is 0. Oh, that's not the right color. Let's say that is 0.0004 coulombs. Okay, so we've got values for both charges. We have our values for the force acting on both objects, or both charges. And let's add those to sort of our diagram here. 500 newtons acting on the one on the left, 500 newtons acting on this positive charge on the right. So again, we're going to start this out the same way that we have all of the other problems. We're going to plug in the things that we know and leave the things that we don't know as just sort of like question marks, or I'm going to plug in just an R for this unknown distance. Let's see. Our force is 500 newtons. That is equal to 9 times 10 to the 9th times our 0.005 coulombs times the 0.004. Oh, excuse me. There's an extra 0 there. Okay. So the one piece, again, that we do not know is this r squared, or what this r distance is. So in order to solve for that r, what I'm going to do is I want r to be on its own side. Right now it's trapped over here with this 9 times 10 to the 9th and both of these charges. So in order to cancel that r out or bring it over to the other side, right now we're dividing by r squared. So why don't we go ahead and multiply both sides by r squared? And in the past, I didn't show this little, like, whatever we were multiplying by on the other side, but with this, I've been doing the same thing. So this is not like a new type of step. But we're canceling out our r squared over there. So now we're left with 500 r squared is equal to the rest of the stuff, 9 times 10 to the 9th times that 0.005 times the 0.0004. Okay, but we still are not quite done the algebra part of this problem. So in order to actually solve for the r squared, it's being multiplied by 500 right now. And if I want to get r squared by itself, I need to cancel out this 500, do the opposite of multiplication. So I'm going to divide both sides by whatever it's being multiplied by. In this case, that is 500. So I'm dividing both sides of this by 500. So that's going to leave me with r squared is equal to 9 times 10 to the 9th times 0.005 times 0.0004, all divided by 500. Okay, so now we're at a step where we should probably plug some stuff into the calculator. In fact, I could have a little earlier and it might have saved me some writing, but just for the sake of completeness, I'll show all of you. So let's see, 9 times 10. Now I'm clicking again for this exponent, the x to the y button, 9. I'll just hit enter there. And then times 0.005 times 0.0004. And then we're dividing by 500. Okay, so what we found is that r squared is equal to 36. Okay, but the question for us wasn't what is r squared, right? We don't really usually care about what the distance squared between two things is. You don't really know off the top of your head, unless you're strange, what the distance between you and school is, or the distance between you and Florida is. We know what the distance itself is, not a distance squared. So let's take some algebraic step to get r by itself and not r squared. So right now it's being squared, and in order to cancel that out or to get r by itself, we need to take the square root, that's the opposite of squaring something, on both sides. That's going to leave us with r is equal to, and for you math sticklers out there, you might say that should be plus or minus 6. We can't really have negative distances, so I'm just going to take the positive version of that and say that r, our distance, is 6 meters. So again, these are the most complicated, I think the most complicated, for me certainly, the most difficult and algebraically involved applications with Coulomb's law, but that is sort of the last type of problem. We can solve for the force. That's the easiest type of problem because the equation is already set up for us. We can solve for a missing charge, and we can solve for a distance as we did here.